Hello. In this video, we are going to review parabola as a locus, just the idea of it, and also how to write its equation using different pieces of given information. Okay, so what is given is a line called directrix and a point called focus. We are looking for all points equidistant from the focus and directrix. Okay, let's try to find these points visually. So one point equidistant from focus and line would be like clearly right between them. But then if you try to look at to the right, for instance, we cannot have a point here, it's too close to the line. This would be too close to the point, but somewhere between them. As you keep going to the right, the point will also have to go higher because it must accommodate the point and the line and higher. So this distance, for instance, they will be more or less the same and higher, more or less the same distances. This is approximate sketch, just the idea. So if you connect them, we are going to get a half of the curve and the other half will be on the other side. This curve turns out to be a parabola, and we are going to prove why is that. Here's the idea again. Every point on this curve must be the same distance to the line and to the point. So these two distances are equal, and that's what we are going to use in writing our equation. This is a huge idea. So the very first step that we need to do in order to write an equation is to call a random point on the parabola xy. This is the key step. Why is that? We are going to write an equation in the form y equals ax squared plus something something. So this equation contains x and y as any curve. And the idea of it is that whenever a point on the curve has coordinates x and y, these coordinates x and y must satisfy this equation. And vice versa. Any xy coordinates that satisfy this equation will determine a point which is on the curve. We need these coordinates x and y to be parts of our equation. So this is our first step. Let's look at the first example. So the given information is directrix y equals 1. So this is the line that we draw at the level 1. And focus is the point 0, 5. So it's right here on the y-axis. Diagram is crucial in this case. It actually dictates to us how to write the equation. So now we are going to sketch the parabola, making sure that the vertex is right here in the middle between the focus and the directrix. And then we draw a parabola, something like that. The focus is inside the parabola and directrix is outside. And then we go to this process. We pick a point anywhere on the curve, call it xy. Pick a random point on the curve. All right, so now we are going to complete our diagram. We are going to show the distances that we are going to equate. Distance from the point to the line and distance from the point to the focus. Let's call them D1 and D2 for communication purpose. And we want to say that they're equal. So let's set up each of these distances. D1. Now, D1 is the distance between 2 points with their coordinates. So we can just use the distance formula, square root of x minus x1 squared. Okay, let's write this formula down. Plus y minus y1 squared. In this case, it's square root of the coordinates of the focus are 0 and 5. So x minus 0 is just x. I don't need to write it. Plus y minus 5 squared. This is my distance. Now, second distance is unusual. It's a vertical distance between the point and the line. The line always has the same level, y equals 1. The x coordinate really doesn't matter here. Think about this. In order to find the distance between two vertical lines all, let's say we have 2, 7 and 2, 3, for instance. What's the distance? It's a 4. It's just difference between the y coordinates. So the x coordinate doesn't matter here. So I can just say it's a distance from y coordinate of this point to this level, which is 1. So it's y minus 1. So all I need to do is set up these two equal. Too much red. Let's do something else. Okay, so we are saying d1 equals d2. In other words, y minus 1, I switched them around, doesn't matter, equals x squared plus y minus 5 squared. This is pretty much an equation of our parabola. It looks ugly though, but it's already the equation that combines x and y and tells us the condition under which the point with coordinates x and y will lie on this curve. But of course it doesn't look pretty, so I'm going to square both sides to get rid of the square root. Y minus 1 squared equals, and this will just unsquare the square root, so y minus 5 squared. Okay, again, I want my equation in the form y equals something something. So I need to square both of these binomials. I'm using perfect square formula, so it's y squared minus double product plus square of 1. X squared is easy. And then perfect square trinomial again. Y squared minus double product 10y plus square of the second 25. Luckily, y squared cancels here. Now, I want y on the left side, so I'm going to add this 10y to the left side, so it will be 8y, and that's all. Everything else I want on the right side. X squared is already on the right, 25 is on the right, so I just need to subtract 1, so it's plus 24. And finally, I'm going to divide everything by 8, so I'm going to have y equals, I'm going to divide 8 into each of these terms, so it will be 1/8 x squared plus 3. This is my equation. Couple more things here. First of all, let's look at the original graph. What's the vertex of this graph? Yeah, between 1 and 5, halfway it's a 3, so that really makes sense. Second comment. You know that there is a shortcut formula that allows you to skip all this work, and the formula says y equals 1 over 4p x minus h squared plus k. So let's look at this carefully. First of all, that looks like a vertex form of the parabola, and h, k is the coordinates of the vertex, are the coordinates of the vertex. And what is p? So p is this distance and this distance. So this is p, this is p. So p is half a distance from focus to directrix. Or you can call it, it's a distance from the vertex to the focus and also from the vertex to the directrix. So in this case, p is from 5 to 3, it's 2. From 3 to 1, it's 2. And as you see in our equation, we would write 1 over 4 times 2. Coordinates of the vertex are 0, 3. It will be x minus nothing, x squared, I don't need this parenthesis, plus 3. That's exactly what we got here. Now you're probably thinking, then why did we need to go through all this pain if all we need to do is just this? In many cases, you really don't need this entire derivation, but there are types of problems where you actually need to do this work and you need to show this work. So yeah, stick with me. The next example will be like 3 times as hard as this one. So if you're struggling with this one already, instead of going to the next page, next screen, maybe just go back, write down the given information, And without watching the video, try to repeat all this whole process and then check yourself. That would be more beneficial for you. Otherwise, welcome to the next page. Okay, let's look at the second example. There are a couple complications here, actually 3 complications. So pay attention, do it slowly, pause when you need. All right, so directrix is the same as in the previous example, y equals 1, and a vertex is given. Please notice, it's a vertex, not the focus given. So we need to determine the focus first. What we need to understand is the vertex is always halfway from the directrix and the focus. Also, directrix is always outside and the focus is inside the parabola. Therefore, how will our parabola go? Think. Alright, so it must turn away from the directrix. It must go down from the vertex. And the focus must be inside. How far inside? We know that this distance must be the same because vertex is equidistant. So that already gives us our P. It gives us the vertex first of all. The coordinates will be 2, comma. So we go 3 unit down. This is 3. So this must be 3 again. So it's -5. So now we know the focus. We need to label clearly. So we don't mix them up and don't make mistakes. But the good news is we can actually write the equation now using the shortcut. So the P is 3, except because our parabola is facing downwards, it must be negative. So it will be -1 over 4P, which is 4 times 3. Now, coordinates of the vertex, x minus 2 squared minus 5. We're done. So if you face a multiple choice or short response question, this is all you need to do. Writing equation is easy, but you need to prepare yourself by drawing a nice diagram and figuring out what is what and finding your P. But if you need to do it algebraically, we have to go through this whole painful process. Okay, step 1. Pick a point anywhere on the parabola, call it xy. So this xy will be part of our equation. Show the distances. So distance from the point to the line and distance from the point to the focus. I actually don't like that I labeled the focus and the vertex and the focus on my diagram because I already made a mistake. I'm re-recording it because first time I connected this point with the vertex. So pay attention. It's a distance from the point to the line and point to the focus. They don't look equal, but it's okay. It's just a sketch. Let's call this D1 and D2. All right. So D1 is my distance from the point with vertical coordinate y to the line with the vertical coordinate 1. That's all that matters. X coordinate is not part of this distance, so I can just write its distance from. But I cannot write y minus 1 because my y is actually lower and this answer will be negative. So I need to subtract bigger minus smaller. Or I can just take absolute value of this. Then I don't need to worry what is higher, what is lower. Second distance is, I'm using distance formula between these 2 points. So I'm looking at my x coordinates, x and 2, and the y coordinates, y and -5. Square root, so x minus 2 squared plus y minus -5, which is plus 5 squared. And I'm claiming that these are equal. So I'm setting them up equal. 1 minus y equals square root x minus 2 squared plus y plus 5 squared. I'm going to square both sides. I'll just do this. So 1 minus y square, I'm going to square it. It will be square of the 1 minus double product plus square of y equals. I can expand x minus 2 squared as well, but I don't want to. Why? Look, this is the form we want our answer to be in. And as you see, x minus 2 squared goes here unbroken. So I really don't want to split it. I want to keep it as is. Otherwise, we will have to complete the square. Plus, this I really want to expand because I need to simplify it in terms of y. I need to isolate my y. So double product is 10y and square of the second. Luckily, as usual, y square cancels. Now, where do I want my y? I want y separate, but I don't want it on the left because it will be negative. So instead, I'm going to add 2y to both sides. So I'll have 12y on the right. Everything else I want on the left. X minus 2 squared goes to the left, so I need to subtract it from both sides. And 25, I need to subtract from both sides, so it becomes minus 24. And finally, I divide by 12, and I want my y on the left, so I just divide everything by 12, minus 1 over 12, x minus 2 squared, and minus 24 by 12 is 2. Oh, look. Oh, no. Do you see why I said, oh, no? Did you notice my mistake? As I told you before, I messed up here. So the vertex is 2 minus 2. Focus is minus 5. So it's supposed to be minus 2 here. The reason I decided not to re-record this video, two reasons. First, I'm lazy. But second, I just wanted to show you how important it is to look at your diagram and to see if all components make sense. So I noticed that originally they didn't match, so there would be a mistake. I wasn't sure where. So this is a good lesson that you have to be very careful. Vertex is the part of the equation. Focus is the part of the process. That's where we're using the coordinates of the focus. And all three of them, directrix, vertex, focus, must be the important parts of your setting. I would say in this entire process, the correct diagram, including setting up distances, like understanding which distances must be equal, this is half of your success. Okay.